Things that you need to know how to do is to minimize functions using char-maps. So before going to that, char-map is, if you have viewed my video, you probably will have know what is a char-map. If you're given a Boolean expression, so this is my expressions here, you need to be able to put that into a char-map, and then how to minimize that from the char-map. This is a very simple Boolean expressions, two variables, and then we have a bunch of products, and then they are summed together. So this expression is called sum of products. We have products here. We got products term, and then all these product terms are summed together, and we call sum of products. How you can put this into char-map? First, you either put it into a truth tables, and then you can map from the truth tables to the char-map. That is basic procedure, what you need to do. But this is a very simple function. How do I draw up my truth table? I got two variables x, y. I got x bar, y. So x bar means x is 0, and with y means that x is 0, y is 1. I'll get a 1 in my functions. This term is my x bar y. And then I have x y bar, which means that x is 1, y is 0. So this is my x y bar. I'll get a 1 in my functions. And then here is x and y. I got a 1 in my functions. In terms of decimal equivalence of this truth table, this is 0, 1, 2, 3. The binary equivalence of this x and y. And how do I map it into my char-maps? My char-map is drawn as a grid of, in this case here is 2 by 2. I got two variables. To account for all my variables, x and y. And then I need to have all the state of my x and y. X go from x bar to x, and then y go from y bar to y. These are all the state of my variable. And then each location of my grid corresponds to, it's just like a graph. So this here is correspond to x bar, y bar. So basically this is this location here of my truth table. I got a 1 there, I'll put a 1 in my grid. And here is x bar, y. I got a 1 in my truth table, I'll put a 1 there. And then x, y bar, I got a 1 in my truth table, I put a 1 there. And then x, y, I put a 1 there. Here at the bottom, I put down a red color, 0, 1, 2, 3. And that is corresponds to these columns here, which is my decimal equivalence of my binary number. Basically, I'm mapping this into here. That is how you put from the truth table to a char-map. So this is a very simple two variables, so it's only a 2 by 2 grid. To write it in terms of sum of products, my function xy can also be written as this is sum, and what is inside here is a products term. The products term here is referred to my decimal equivalence of the value of the binary variable. Here, as the one that I have a 1, I'll put a 1 in my products term, and then 2 will be this, and then 3 with this. This one here is this one, And then this one here is this. And then my 2 is the other one, which is the red one. That is how you can write. An alternative way of writing this is called sum of products, and it's written as with the summation terms, and then the brackets with all the terms that has a 1 in my truth table. This is mapping from functions to truth table to care map. This is a simple example. Again, my truth table 0, 1, 0, 1, 0, 0, 1, 1. X bar y, that will be this term here, x bar y, I got a 1. And then x, y bar, x is 1, y bar is 0, x, y bar is this. In terms of my sum of products, I'll write it as 0, 1, 2. Sorry, I shouldn't have 0 there. So it's just a sum of 1 and 2. Only these two products terms appear in my sum of products. So in terms of care map, we go 0, 1, and then 1, 0. Very simple for 2 variables, but we extend it to 3 and to 4, then you have to know how to do that as well. For this one, because it's so simple, it's 2 variable, and then all the sum products has 2 variable in it. You don't really need to draw the truth table. You can actually read it off from there. So x bar, y bar, this is actually 0, 0, 0. X, y bar, this is 1, 0. So 0, 0 is 0, 1, 0 is 2, your binary equivalent. This is simply 0, 2. Again, this one, 3 variables, each of the sum terms. Now, each of the products terms also has 3 variables in it. So again, you can write down like before. I'll show the first one. This is 0, 0, 0, 1. So this indicates a term of 1 in my products. You can do the rest. If you haven't get what I meant by 001, this is a 3-bit binary number. X bar, bar indicate it is 0, y bar indicate it is 0, and then without a bar is a 1. So again, X, there's a bar, there's a 0. Y, no bar, is 1. Z is 1. So 0, 1, 1. What is 0, 1, 1? 3, yes. So this is 1, 0, 0, 4. And then this is 1, 0, 1. This is 5. 3, 4, 5. For 1, because this is what we call, this is called standard form. We have 2 variables. All my products has 2 variables. This is what we call a standard form. or another term is called canonical form. Standard form or canonical means that if my function has two variables, all my product terms have two variables, then it's called a standard form. So my sum of products consists of two variables if I have two variables in that, and then three variables if I have three variables in my functions. This is called standard form or canonical form. How about this one? Now you can see that I got three variables, my function x, y, and z, but my products term only got two variables. This is a non-standard form or non-canonical form. We can't write down straight away like before. I can't identify whether this is a three binary number and then convert it into a product term. For this sort of functions, put down hints there. You have to first write down the truth table, and then from the truth table you can work out what is the sum of products of that. So my x bar, y bar, another way to do this, you can, if you get familiar with all this, you can actually skip all this. Because if you see, x bar, y bar is when my x and y is 0. Then I have a 1 at the output. And then xy Again, means that if x and y is 1, I'll have an output of 1. Yes? Sorry, I can't hear you. XZ, yes, correct. Is XZ. Meaning that X and Z need to be 1. Sum of products. Or this one we know this is, we go from 0, 1, 2, 3, 4, 5, 6, 7. We know that is 0 there, there's a 1 there, there's 5 there, there's 7. So what is missing? Someone says 3. Others, do you know why 3 is missing? My truth table. X bar, this columns here, X bar, Y, and Z. These 3 columns need to have a 1. There will be this. I'll go 1. Or alternatively, X bar, Y bar, Z bar, which means that is 0, 1, 1 in my variable. Then I have a 1 at the output. Then I'll have my 3 terms there. This is for 3 variables. This sort of function is called a non-canonical function or a non-standard form because we have more variables, but the product terms has less variable compared to all the variable in the functions. Question could ask, let's say, given in these functions, ask you to convert it into a canonical form. So a canonical form means that it will be in this sum of products, and that will be in a canonical form. So this can also be called or standard from sum of products. This is 3 variables, 4 variables. So now we have A, B, C, D. I'm not going to work out all the products terms. I'll use what I've said just now, identify from A, B, C, and D, and then deduce what is the F functions from this. What I'm trying to write there is the decimal equivalents. Draw out the truth tables and see whether you can find the function F. First term, A, B bar, means that A is 0, B is 0. These are the terms when A and B are 0. This is the term that I'll get a 1 in my functions. This one? So no bar, meaning that it's 1. My A is 1, B is 1, C is 1. That will be this, and this. My A, B, C is 1, and this. This one? A is 1, B is 0, C is 1. A is 1, D is 1. I got 1 here. Here is already have a 1, so it doesn't need to do anything. There you go, 1 there. Here, it's a 1 here. And then the last one there, so you got an existing 1 there. What is the sum of the products term? Decimal equivalent, I got 0, 1, 2, 3, nothing there. 4, 5, 6, 7, 8, I got a 9, 10, 11, 13, 14, 15. Do you know how to put from functions to truth table now? Everyone know that? Up to 4 variables, you can do that, yeah. And then how do you convert from the truth table to a sum of products in canonical form?